So the two-column proof. The two-column proof. Proofs, in general, are logical arguments that show a statement is true. Logical, right? There are several forms for the proofs. We're looking at two-column proofs. So we're using numbered statements with corresponding reasoning. So statement 1 has reason 1, statement 2 has reason 2. And it shows an argument in a very logical way. So here's your statement. So each statement in this column is either something you're told, you're given, or the result of applying some kind of known property or fact to statements that we've already established. And then each reason kind of explains the statement. So it goes with the corresponding statement. And we've seen this, right? We've been working with it. What else about that? You make one statement at a time. I will say sometimes you can combine very similar statements, and you may see some examples of this. If it's very similar with the same reason, sometimes we combine it. But generally speaking, one statement at a time. And because you're making statements based on fact, what kind of reasoning are we using? Inductive or deductive? Deductive, right? So it's very deductive. Now, the comment made before was, but I'm good at deductive. I'm very good at patterns. So that I'm useless, right? Not really, because inductive reasoning is how you come up with the ideas that you're trying to prove deductively. Inductive reasoning is extremely important. Extremely important. We would have nothing to prove deductively if we couldn't think inductively. So it's a very good thing to be good at inductive reasoning. So we're going to train up our deductive side as well. So usually, but not always, the first statement in reason pair is a given. You know, you look at what they're telling you. But sometimes you may put that in at other times. It doesn't have to be first. If you don't know how to start, it's a good place to start. So let's look at this one. And we've done stuff like this, but just to kind of reiterate. So I'm given 2AB equals AC. So twice AB equals AC. Prove that AB equals AC. And I think what I'll do here is I'll just kind of pop it up. Oops, I didn't pop it here. I thought I did first. Okay, so what do I want to do here? So I know, let's see. Let's kind of do this off the cuff here. AB plus BC equals what? AC? Let's see if that helps us. Oh, I didn't understand what I'm trying to say. That is what I wanted to do. That is segment addition, right? And then I'm going to say 2AB equals AB plus AC. Well, how come? What did I change from here to here? This thing, right? Why am I allowed to change that? Yeah, how come? Because they're different statements. Yeah, because up here it says they are the same thing. So you can interchange them. That is a transitive property. It's also substitution. I will take that as well. You're substituting a value in. And then I got here, which is what I'm trying to prove. How did I get there? How did I get there? Yeah? No, what am I subtracting from both sides? I subtracted AB from both sides. Gets rid of that. You have two ABs, take away an AB. You get AB equals BC, using that subtraction property of equality. So you are really she's starting to get that thinking. And she struggled with it, right? She struggled with it. But it's getting in there. And so it's a little struggle at first, but it does. You start thinking like, okay, I see how they want me to play this game. So you always want to sketch your diagram first. You want to give a reason for all statements, including the last, especially the last. And reasons must be based on fact. You can't say, well, it's obvious. Because that is like, and then a miracle occurs. It's only obvious if we have a postulate for it. We can't just say that. So what's a theorem then? A theorem is the reason used in a proof, besides the definitions, properties, and postulates. So remember what we said about postulates. We want to have the minimum number of them. So we want to minimize the number of postulates. These are our assumptions. Because, again, our whole logic sequence, our whole geometry will fall apart if any of these are false. So we minimize that, and then we prove everything else, and proving is what the theorem does. So theorems are statements, conjectures, that we have proven. Once we've proven them, we can use them to prove other things. Okay, so we're going to work on building a list of theorems. So, segment, angle, congruence theorems. Question?
I was wondering, what's the definition of what's a property?
Can I take that offline in a moment? Can you write it down, and I'll get to that question? Only because it's interrupting the flow a little bit. If you can just write that down, I will get to that. Okay. So segment and angle congruence. Remember these properties, reflective, symmetric, and transitive? Symmetric, right? We talked about those. Reflexive states that if you have a segment, these should be four congruents here. AB is congruent to AB. Now that makes sense, right? It can be congruent to itself. Obviously, it's going to have the same measure. Symmetric says if you have AB congruent to CD, then CD is congruent to AB. And the transitive, right? This is all very familiar with me, I hope. AB congruent to CD, and CD congruent to EF, and AB is congruent to EF. Now these are going to be theorems. I have to kind of prove these before I can use them. Okay? We have similar ones for angles. So reflexive angle says that angle A is congruent to angle A. What do you think the symmetric property, or symmetric theorem for angles would be? If angle A congruent to angle B, what's the conclusion? The symmetric? Yeah? What's it going to be, Abby?
Angle B congruent to angle A.
Excellent. Okay. And transitive. An angle A congruent to angle B, and angle B congruent to angle C. Yeah, Amanda?
Then angle A is congruent to angle C.
Excellent. Okay, so we understand what reflexive means, we understand what symmetric means, we understand what transitive means, so why can't we just use it? Why do I have to prove it? Well, I don't want to make any assumptions that I don't have to. So we're going to go and prove them, and I'll show you how. So here's the reflexive theorem of congruence for segments. So this is a little bit jumpy on the page here. This one is on the left side, reflexive theorem of segment congruence. So what you're given is a line segment. I'm going to call it AB, and I want to prove it's congruent to itself. Seems trivial, and it kind of is, but I can't just say because it's obvious. Yes, sir?
Wait, so you're saying we can't, so we're saying we have to pretty much prove that
Yes.
5 equals 5?
No. Equality or properties, we can accept equality. This is congruence. Congruence is not equality, it's something else. So I don't have properties, I have to prove my theorems. Once I've proven them, I can use them. And you're right, it seems silly, it's obvious. However, the less things that are postulates, the better. And it's easy to prove, because watch. AB is a line segment, who says? Look up here, it's here. All right, now watch what we're doing here. The measure of AB equals the measure of AB. How come? Well, that's the reflexive property of equality. We have this property, so I'm using that, and now it's just a step away to say this. Because why now can I say AB is congruent, my little congruence thing come out here, to AB? Because that's what congruent segments are. If you have two segments with the same measure, then they are congruent. That's a definition. And kind of getting back to your statement about what's a definition, we talked a little bit about formal definitions. In segment is a line with two endpoints. That's a definition. Now, what does congruent mean? Congruent, the definition of congruent is they have the same measures. So now that I have segments with the same measures, I can say they're congruent by definition. What? Yes. I am proving it for congruence. I know it, it's a given fact for equality, and now I'm proving it for congruence. So now that this is proven, if I have a theorem where I need to show the reflexive property of two segments, I can. I can't assume it's true just because it looks it. Or I mean, I know this is going to be true, but I have to prove it. The less that is based on assumption, the better. Yeah, it's silly, but bear with me. Now the angles, I want to prove reflection for angles as well. Very similar, right? Give me an angle. Okay, here's an angle. I know that the measures are reflexive because they're numbers and we have a reflexive property of equality. But I can turn now that I know the measures are equal. By definition, what definition? The angles are equal, or congruent rather, because that's what congruent angles are. If you have two angles with the same measure, you have congruent angles. So it's just like, well, this is silly. Well, maybe, but I have now proven without a shadow of a doubt. So if for some reason in another proof I need to make a statement that this is angle A congruent to angle A, I can use this theorem as a reason. All right, let's go with ones that are maybe slightly more interesting. Symmetric property, or theorem. So remember what symmetric of equality is. If you have A equals B, right, then B equals A. That's the metric property of equality. Well, now I want to prove it for congruence. So I'm given two congruent segments, AB and CD are congruent. I'm given that, okay? So let's see. If I have two congruent segments, then their measures are equal. That's what this says. Why is that? Yes? Yes, the definition of what congruent segments are. They are segments that have the same measure. Awesome. What do you think's going to happen now?
A miracle.
No. No miracles. We're going to say, well, if AB equals CD equals, then CD equals AB. How come? How come, Evan? Symmetric property of equality. This is true for equals. We have that property. And so now I'm going to say, well, that's awesome, but I can leap to the conclusion I want now that these are congruent. How come? Because if you have two segments that have the same measure, they are congruent by definition of what congruent segments are. You see what we're doing here? I mean, it's like, what? This is ridiculous. Hey, I have proven this. As long as this property doesn't fall apart, this is proven deductively with facts. Yes. He's very unhappy, Jack.
What if 5 is secretly 4?
What's that got to do with this? We're using the assumption that equality is true. You're right. If the properties of equality are proven false, we're in trouble. But so far we've made it several thousand years, it's fine. All right, now angles, we're going to do the same thing. So I have two congruent angles. I want to show that that's symmetric. That I want to conclude that B is congruent to A. So let's see. I'm going to look at their measures, and I'm going to say they're equal. Well, why are their measures equal? Well, that's what congruence is. If you have congruent angles, their measures are equal by definition. That's what congruence means. Now I'm going to use the symmetric property of equality to turn their measures around, because those are numbers, right? I can just use the equality property, symmetric property. And now I'm going to work backwards. Well, if their measures are equal, then the angles are congruent by definition of what congruence means. See what we're doing here?
Yes.
Okay, good. Thank you for the feedback. All right, let's see. Now, we also have transitive. This comes in handy, so I would want a theorem that I can use it for congruence. So I've got two sets of congruent segments. AB is congruent to CD, and CD is congruent to EF. So I want to prove that AB and EF will also be congruent. So I'll start with my givens. What do you think we should do next? It tells you, but well, what do you think we should do next, without even looking at the paper? I have some congruent segments. What's a good idea? Now, what do you think, Joseph? Yeah, let's look at their measures. Because they are congruent, their measures are equal. That's what congruence means. If they are congruent, measures are equal. Now, I have transitive theorem, transitive property of equality, right? If AB equals CD and CD equals EF, then AB equals EF. That's the transitive property of equality. And now, once I have two measures that are equal, I can make the leap that they are congruent segments, because that's what congruence means. If you have the same measures, they are congruent. If they're congruent, they have the same measures. And we're going to do a very similar thing for the angles. We've got angle A congruent to angle B, and angle B congruent to angle C. So we're given that situation. We want to be able to conclude that angle A and angle C are congruent. So let's see. I'm not telling you, am I? So what's going to happen in this next statement here? What's going to happen? What are you thinking? Yes, awesome. So because I have congruence, that means the measures of these angles are equal. And why is that? Why can I say that, Amy? Yeah, this is what congruence means. If you have congruent angles, by definition, their measurements are equal. Okay, what are we going to do next? What do you think, Jacob?
Measure of angle A equals the measure of angle C.
Good. The measure of angle A equals the measure of angle C. How come?
Oh, transitive.
Transitive property of equality, right? Because we're working with equals now. We have that property, so I'm using it. What's our next step? Now? Yeah, Amanda?
Angle A is congruent to angle C.
Yep, how
What
come?
is the definition of congruent angle?
Beautiful. That's exactly right. So we're playing games here, but hey, it's a game that works. Now I can say segments have the transitive property. They have a theorem that shows it. It's kind of awesome. It helps us. It's going to help us later. That's awesome. Really?
Yeah.
Yeah, I think it is. Good. All right, so let's look at now. Name the theorem. Name the theorem. Not on your paper here. It's a little game show. Now that we have proven our new theorems, we can use them. What theorem is used to draw the conclusion? So just look up. It's not on your paper. So if angle R is congruent to angle T, and angle T is congruent to angle P, then angle R congruent to angle P. Who says? Yes, sir. That.
The reflexive theorem of angle congruence.
Is this reflexive?
I mean
Got
the transitive.
Transitive theorem of angle congruence. The theorem now, right? When we talk about equality, we say property. Now we've got a theorem that says so. What about this? If segment NK is congruent to segment BD, then BD congruent to NK. How come I can make that a conclusion? Amanda, how come?
That would be the symmetrical theorem of segment congruence.
Beautiful.
Hey, you revealed the answer I was saying.
I know, because you were saying the correct thing. You were saying the correct thing.
That was cheating.
Oh, I said you had it out. All right, CD congruent to CD. Who says I can say that? Abby? There you go. This is the important part. If I was using this in a proof, I'm looking for this. I know you need that part. And let's see what else we got here. If angle Q congruent to angle B, then angle B is congruent to angle Q. Jacob, what's that? There we go. So excellent. I know you know it's symmetric, and I know you know all that, but now we're using those words theorem because we've proven these. They're not such properties anymore. So now we're going to try and do some proofs. Okay. So what's the first step? Mark your diagram. You don't even think about, let's write some stuff down yet. So let's see, AD, the length of AD is 8. The length of BC is 8. So wait a second, they have the same measures, therefore they are congruent. I'm going to put some congruence markers in. Okay, because I can see that. All right, what else do I know? BC, this one, is congruent to CD. And I want to prove AD is CD. Now, by marking up the diagram, can't we see that's true? Can't we see? So we're convinced already. So the important part is you have to believe it before you can even think about proving it. So let's see if we can prove it. And this is one where I'm pretty much giving it statements. And we have to come up with some reasons. So AD equals 8, BC equals 8. That's given, right? Okay. So I'm going to say that AD equals BC. How come? Why is that, Joseph? I can't hear you. What? Nice and loud. Well, what if it's wrong? If I say it low, it can't be wrong. What is it? Yeah, so why, which rule says that? Oh no. A equals B and B equals C. So A equals C. Help me out. Transitive, right? Isn't it transitive? Or substitution, either one. Transitive property of equality. Now we're working with equals. You said substitution, and I would accept it. So, since AD equals BC, segment AD congruent to BC. How come? Well, how did I get from here to here? I get there, Kaya. Well, it looked like a hand up to me. No, it wasn't, it wasn't. What? Well, how come? How come? Look at this. Measures, and now I'm saying they're congruent. Equal measures, now they're congruent. Why? Oh, somebody else around. Why? We just did a whole bunch of proofs using this. Amanda, how come?
Because the definition of congruent segments.
Yeah. Basically, the definition of congruence of anything, right, states if their measures are the same, then they are congruent. Now, we just did a whole bunch with that. So it lets us go back and forth from equal to congruent or congruent to equal. Now I'm saying BC congruent to CD. Where's that coming from? Yes? It's given. It's up here. So here's a case where I didn't do all my givens all at once. I felt it was maybe a little more logical to do it that way. You don't have, you could have put it up here. But, remember, there's more than one way to do a proof. For me, this kind of flowed a little better. And so now I'm concluding that AD equals CD. How come? Look at these two statements. Jack, how come?
The transitive theorem.
Transitive theorem? Yes. Because I've got AD congruent to BC, BC congruent to CD, therefore AD congruent to CD. I don't have to prove this again. I already proved it, that we have transitivity for segments, so now I can use it. Otherwise, I would have had to go through the whole measure thing all over again. So that's the usefulness of having proven it. What do you think? There's absolutely no comment.
I think that's very cool.
I think it's very cool too. Yes.
It's like creating your own Lego. What's the difference between using subject
Awesome. What's the difference between the this is such a great question. She says, what's the difference? Why can't I just say transitive property of equality for the bottom one? What's the difference between these two things? So you'll see, like I always put these words on here. If you look at other proofs and other books, they often don't add that on there. Because equality and congruence are two different things. So here is equality. And we have a property that states for equality, like if I would have had something else here, and I'm just making this up, right? That is the transitive property of equality. Those are numbers. So if two numbers equal the same number, those numbers are equal. These are not numbers. Congruence compares physical segments or angles or whatever we're looking at. It's saying they have the same measure. That's what that means. Doesn't mean they're equal. It means AD and BC have the same measure. BC and CD have the same measure. Therefore, AD and CD have the same measure. It's slightly different. Now, because we know it's true for equality, it doesn't mean it's true for anything else unless we prove it. So the theorem is proof for congruence. Properties is an assumption, I guess, or a given for equality. Now, I don't know if I'm answering your question. It's the same general idea. It's just one works on equality and one works on congruence. Yes?
You could get at some of those properties as well.
Oh, yeah. Yes.
There was an angle that was like made up of line segments and another one made of lines and had the same degree where they both congruent.
So if you have an angle like this,
Yeah, and one line would have the same measure as this.
he wants to know if this angle was 35 degrees and this angle was 35 degrees, are they congruent? What do you guys think? What's the definition of congruence for angles, say? What do you think, Amanda?
Congruent angles are angles with the same measure.
Okay. So are these going to be congruent angles, even though they're formed slightly differently? Yes. Look, you guys are smart. What a nice question. All righty, let's look at this proof. We're on a roll. We're on a roll. Okay, so let's see what's going on here. First step, always mark up the diagram, right? Segment AD is 12. AD, oh, that's over here. Segment AB is 12. Well, I'm noticing because they have the same measure, I think I'll mark them congruent. Right? I can see that. I also know that BC is congruent to CD and AD is congruent to CD. Oh my goodness. So BC is congruent to CD. So first I'm making them different because I don't know anything else. But then it's saying AD and CD are congruent. So this one and this one are congruent, which means that one's, they're all congruent. Do we kind of see that just by marking up the diagram? I couldn't tell that maybe by just looking at this, but I can see that by marking up the diagram. So now what do they want me to prove? BC and AB are congruent. Can we see just from marking up the diagram that that's going to be true?
No.
No? To me, it looks like all those sides are going to be congruent. So convince yourself. Because if you don't believe it, it's very, very hard to do a proof. If you really don't believe it, that can happen. Right? We chased it around. It turns out they're all congruent. All right. So let's see where I'm going here. AB equals AB. How come? Yeah, how come, Amanda?
Because of the transitive property of equality.
Yeah, right? Because they both equal the same thing, therefore they're equal to each other. That's transitivity. So now I'm stating that their measures are equal, so they are congruent. How come? Yeah, how come? Yeah, the definition of how congruence works. Okay. Then I'm saying BC congruent to CD, AB congruent to CD. Really? Where's that coming from?
Wait, I'm still on like the grade side.
That's okay. Yeah, where's it come from, Ellie? They told us. Exactly. Given's right here. Nice. So far, this one's easy. All right, let's see what happens now. BC congruent to AD. What? Oh, how come? How come? Look at that. Why is that? Look at this, Dave, and now look at this one. Amy, what do you think? Transitive theorem, right? There we go. So we're recognizing that transitivity. And then what was my final statement there? I want BC equal to AB. Well, where'd that come from? Oh. Well, this one's AD. But let's look what's going on here. AD equals AD. AD equals BC. So AB equals B, right? So I think we got another case of transitivity here. So the transitive theorem comes into play again. So you're kind of looking up and around. Whoa, there it is. Questions? It's a different way of thinking. Very, very logical. Oh, another one? Oh, okay, let's mark up our diagram. Angle ABC congruent to CBD. ABC, that's this one, congruent to CBD. Where's that? That's this one? Okay, I think that's those two, right? And then what? Angle CBD is 50. Now they told us that. Okay, so this one's 50. Oh, what does that mean for this one? It's going to be 50. So I'm just like working with my diagram. And CBE, whole thing is going to be 100. What does that say about this little piece? Right? If this piece is 50 and the whole thing's 100, what is DBE? 50. Now, what if they want us to conclude that ABC and DBE are the same? Oh, I see it now, right? Marking up the diagram. Okay, I see what they did. Let's see if we can get there. I'm using formal proof. So, okay, here's all my givens. So something plus something equals the measure of CBE. Let's see if we can figure out what goes there. All right, so where's CBE? CBE, that's this one. What two angles are going to add up to give us the measure of CBE? What do you think, Amy? Yes, she's saying, how about why don't we add up the little pieces, CBD and DBD? That's exactly what I said. How come? Oh, what's that theorem that says if you add up the two pieces of an angle, you get the big angle? Yep, angle. Angle, what am I doing? I'm adding them up to get the big thing. Angle addition. That's our angle addition postulate. Alrighty. So 50 plus the measure of angle DBE equals 100. Now how do I get that? Oh, where'd that come from? I and change this to a 50, change that to 100. Where'd that come from? Where'd you go? What do you think, Jacob?
Substitution.
Yeah, because I know this one equals 50, so I substituted there. This one equals 100, so I substituted there. Substitution. The measure of angle DBE equals 50. Oh, what's that one? What's that one? Yes? Yes. Subtraction property of equality. Subtract 50 from both sides. Right? So it's like solving an equation here. Subtraction property of equality. Okay. And that was all that work just to get what we kind of saw right away. Regarding this one is 50. So now the measure of angle CBD equals something. Oh, okay. So DBE is 50. CBD, whoops, I'm going to do this one. CBD is DBE. Wait a second, how come? Right, I know CBD is 50, I know DBE is 50, therefore, they're equal to each other by the transitive property. What? This one's a little tricky. You see this one? Yeah? No?
No.
Yeah? No? You don't see it? All right. So DBE is 50, right? And so is CBD.
Oh,
They're both
I get it.
50 degrees, therefore I can say their measures are equal. Okay? And so, this one's all the way gray. What do they want me to say?
Numbers and numbers.
What?
Big numbers and numbers, man.
Let me see. What if I give you the reason? What could I say now? I'm using the definition of congruence, so what do you think's coming here? What do you think, Jacob?
Angle CBD is congruent to angle DBE.
Excellent. Right, I popped it back out. So now I'm looking at congruent angles. And I'm going to get to my conclusion now. I'm going to say that ABC and DBE are congruent angles. Where did that come from? Yeah? Okay, so why is this one the transitive theorem? Where are we getting the transitivity from? Now I need something with ABC, right? ABC is congruent to CBD. CBD is congruent to DBE. Therefore, ABC and DBE are congruent. Wow, we really had to look around a lot for that one. But we did it. You got it.
Yeah.
We did it. Congratulations. No miracles, right? Good logic. All right, another one. What?
What was the last one? What was the last reason for that?
Oh, the last one was the transitive property, right? Theorem. Excuse me. The transitive theorem. I'm working with congruence here. Because ABC is congruent to CBD and CBD is congruent to DBE, ABC is congruent to DBE. Yes, sir.
I think I'll say theorem. It sounds so much like a theory.
Listen, I got nothing to do with that. Got nothing to do with that.
Theory of
All
road.
right, let's look at this one. I think this is close to being our last proof for now. All right, so what's our given? Mark up diagrams, right? AB congruent to BC. AB congruent to BC. Got it. BC congruent to CD. Okay? And CD is congruent to AB. So they're basically telling us 4 congruent pieces. We want to prove that the perimeter of ABCD, this quadrilateral here, is 4 times the measure of AB. Well, what is perimeter again? What's perimeter? Distance around, right? So if it's all the same distance, does that kind of make sense? 4 times 1, yeah. All right, so okay, I believe it. Let's see how we're going to prove this. So I'm starting with my givens, and then how did I get down here? I've got they're all congruent, and now I'm saying they're all equal. Where's that coming from? Amanda, where's that coming from? I thought I saw your hand up.
Wait,
Right, if you're here and I go
Yeah.
here. Yeah, well, how
I
come?
was just stretching the lines because
Okay.
I think it's the definition of congruent.
I agree, right? If they're congruent, their measures are equal. Well, let's see what's happening here. Then it says AB equals CD and AB equals AD. Okay, what? What happened here? If AB equals CD and AB equals, yeah, wait there. Yeah, how come transitive? You're right.
Because, into AB equals BC.
Yeah, got this one, AB equals BC, BC, so there's AB equals CD. Now, if I believe AB equals CD and CD equals AB, right? So I'm kind of using the transitive property right here again. Okay. So the perimeter of ABCD is you add the sides up. AP plus BC plus CD equals AB. And the reason for that is, yeah, what do you think it is? Exactly, beautiful. Right? And that's what perimeters are. You add up the side lengths. So that's the definition of perimeter. Very nice. You guys are getting the hang of this. That's good. All right, let's see. Now, what do you think we're going to do now? I'll give you a little hint here. So this notation that I'm using means the perimeter of ABCD. That's what this means. So for one, which is not wanting to write that all out again. AB plus AB plus. Where did that come from? Yeah, Jack? Yeah, I substituted in all the values because AB, CD is the same, right? They all equal AB. So, what's this one? Substitution. And now, voila, right? I can say it's 4AB because of what? Just I simplified it. Yeah. A simple mathematics, simple arithmetic. AB plus AB plus AB is 4ABs, and look at that, we did it. We okay? Brain still intact? Yeah? No, no. I mean, some people have lost them. They're putting back in. Just stuff them back in.
I might have on one last.
Alrighty.
Wait, what was that?
Oh, sorry, I'll go back. Okay. So now we did talk about, maybe we didn't talk about it. So there are other ways to do proofs. You can actually talk them out. So you could say, well, we know that this is true because of the definition of congruence segment. So a paragraph proof is basically this spoken out. So I'm not sure I'm ready to go there yet. I'll show you what a paragraph proof looks like. I think that's what I've got here. So solve for x, explain your stuff. So angle D, that's this one, right, is congruent to DEG. So this one is congruent to that one, which means that if this is 4x, then this is 4x, right? That's what congruence means. They're going to have the same measure. And this segment EG bisects angle DEF. What does bisect mean? He looks at me, she's like, chop it in half. What does that mean? Cuts it, yeah. Equal pieces. So that means if this one's 4x, what's this one? It's also 4x, or they're equal, right? So if I can put a little arc in here. Congruent, 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 right? So if I was to solve this for x, well, how would I set it up? How would I set this up, Evan? 4x equals 2x plus 3. Yep. And then I would solve this. I would subtract 2x from both sides. And I would divide both sides by 2, and I would get x equals 15. That's nice, except I didn't explain anything. Now I think I've got this here in paragraph form. Oh, no, because EG bisects angle D, and there's all these words here. So this is a paragraph proof. What we could do, though, is we can do a 2-column proof. So I'm going to state my givens. And say, well, this takes so much longer than just doing it, you know. But we're being very thorough. Nobody can argue with us if we do this. Nice deductive 2-column proof. So there's statement 1, and there's my given. Okay? So, what can I say now? Because these two things are congruent, that means the measure of angle D equals the measure of angle DEG, right? Definition of congruence, and I'm just going to abbreviate it to definition of congruence. I know it's definition of congruent angles. So let's see, the measure of angle D, well, I'm just writing this out formally. Measure of angle D is 4x, which means that's the measure of angle DEG. That's how I put the 4x up here by substitution. All right, and now I've got this bisector here, so that means that the measure of angle DEG equals the measure of angle GEF by the definition of a bisector. What I'm doing was furiously writing this down. It's okay if you're just following
I
too.
don't understand.
I'm being very formal and I'm going quickly because I can, but it's just to show you where you gotta get to.
I don't understand which one goes first. From the left, or there two one.
Sometimes it doesn't-
Sometimes
Sometimes it doesn't matter the order, this is just how I'm seeing it. There are valid proofs.
Why
Let me
do
finish.
two things go first?
Can I finish?
Impossible.
Can I finish? Let me finish first, okay? So I've got the measure of angle DEG is the measure of GEF. And this one's 4x. So let's see. That means 4x equals 2x plus 30. And how'd I get there?
I don't understand.
What do we understand? Is the measure of DEG 4x?
Measure of DEG for, it doesn't say that.
No, but I concluded it because you have to follow the proof I'm writing.
Given?
No. Amanda, just give me 1 second and let me finish, okay? All right, so we've got these two things by substitution. And I'm kind of getting up here now, right? So now I would say,
I don't understand.
okay, hang on and I will go over it again, but let me finish. So we're going to subtract 2x from both sides using the subtraction property of equality, which means x equals 15 using what property? Division property of equality. So this is solving that problem with 100 different steps. So let's just review. I'm writing down my given, which was these two things are congruent angles, and this is a bisector. D and these measures are equal because these are congruent angles. That's what congruence means. Then I did some substitution to say 4x is DEG. That's like this box, using substitution. And then DEG is GEF because I have a bisector. And then I substituted again to get an equation. And then I'm using just the equation properties. Awful lot of work, right? Awful lot of work to prove the obvious.
I don't even know what the work is.
The point here was, there is nobody now who can say I did this incorrectly.
I did it incorrectly.
Excuse me, please let me finish. I have deductively proven this. Now, are you here yet? Probably not. But it's kind of where you want to be able to get to be able to kind of support every single thing you say. Now, you can do it in paragraph form, which is all these words right here, or you can do it in two-column proof form. In general, when you're first starting out, I think two-column proofs are better. By the time you get, and all of you I know will be math majors in college, you're going to be using this format more than the other, most likely. And I think maybe this is where I kind of want to start. Yeah, I'm going to stop right
I
here.
don't understand.